All right, picking up where we left off, let's take a look at number 14. I believe in my description in the last video I said we completed number 14, but this is number 14. So it wants us to know if this slope is 0 undefined, so this line down here. Remember, we talked about if you can walk on that line, which this little guy can, it has a 0 slope. So the answer to this is a 0 slope. Okay, think of your treadmill. Treadmill flat, it's at the incline of 0. That's a 0 slope. Okay, 15, pretty straightforward. 5/3 x plus 1, it says find the slope. There it is, 5/3 m equals, and the slope, the y-intercept, I'm sorry, b equals +1. All right, so that'd be a multiple choice type question on the exam. Write the slope-intercept form of the equation. So I know the y-intercept is -1. That's down there. So b equals -1. The slope, to me, looks like probably 1, 2, 3, 4, 5, 6, up 6. 1, 2, 3, forward 4. So rise over run 6/4. M equals 6/4, which is 3/2. So that's my slope, and that gives me y equals mx plus b is my answer to that problem. Negative, or 3/2 x minus 1. All right, use the slope and the y-intercept to graph the equation. So I'm going to go to my graph paper, which is probably over here. I don't know what happened to it. I'll grab another piece here. So I have -1/5 x minus 3. So y equals -1/5 x minus 3. So I start at -3. Now I could go down. I'm going to do that. Down 1, forward 5. 1, 2, 3, 4, 5. Or I'm going to go up 1 and back 5. 1, 2, 3, 4, 5. Either way, it makes a straight line. There's my line. Okay. So that is just graphing an equation. All right. Here's a graph. A balloon is released from the top of a building. The graph shows the height of the balloon. So here's the graph. Okay, so that's where we start at. That's where we finish. What does the slope and the y-intercept tell? Well, the slope, this thing right here, this is height over time, so feet per second. This is the rate. The slope is the rate that the balloon is climbing, or rising, or how fast it's going. And the y-intercept is its starting point. So that's the y-intercept. For a similar situation, slope is 70, y-intercept is 900. What can you conclude? It's starting at 900 feet, so the top of maybe a really, really tall building. And its slope is 70 feet per second, so it's rising at 70 feet per second. That's all we're looking at for 18. 19. Let's see here. Find the x and y-intercepts of the line. So x and y-intercepts, that is the x-intercept, plug in 0 for y. So that wipes that out. And I get 2x equals -18. So x equals -9. That's the x-intercept. INT. The y-intercept, plug in 0 for x, and I get 3y equals -18. So y equals -6. That's the y-intercept. Okay, I do the same thing for 20. The x-intercept, plug in 0 for y, -6x equals 18. So x equals, again, dividing by -6 is -3. That's the x-intercept. The y-intercept is just 18 because I plug in 0 for x. I get y equals 18, and then I'm done. So that's the y-intercept. All right, graph the equation. Going back to my graph paper here, y equals 4. That is a 0 slope line. Okay, so I put a dot at y equals 4. Right, this is on the y-axis everywhere 4. Oops, you can't see that. That's my line. So I put a dot at 4, y equals 4, and I graph across. If it would have been, let's say, x equals -2, I would have put a dot on -2, and then I would have drawn this vertical line. That x equals lines have an undefined slope. Okay? All right. Write an equation in point slope form. Y minus y1 equals m times x minus x1 is the point slope formula for the given line through the given point. So, or for the line through the given point with the given slope. So I just have to plug these numbers into this equation. So the y value is negative 6, so it's y plus 6. So minus negative 6 is plus 6 equals 3/5 times x minus 4. It doesn't say slope-intercept, right? So we're done with that one. Same kind of problem here. Y minus 9 equals negative 5/8 x minus 8 is the answer for 23. Okay. 24, line passes through these 2 points. I want to write in point slope, then slope intercept. So I got to find the slope just like I did in that problem a little bit ago. So that's going to give me, hold on, let me restart my watch here. That's going to give me 7, so y2 minus y1, so 7 plus 5. Again, subtracting a negative is really adding, and then negative 3 minus 1. 7 plus 5 is 12, and negative 3 minus 1 is negative 4, which gives me a slope of negative 3. All right, now I have the slope. I'm going to use any one of these points. I'm going to use the 1, negative 5. Okay, so I'm going to go up here for my point slope. All right, that's y, and then here, plus 5 equals my slope, negative 3 times x minus 1. So I've done A. Now I got to do B. Rewrite the equation in slope-intercept form. I'm going to distribute the negative 3 and then subtract the 5. So y plus 5 equals negative 3x plus 3. Negative 3 times negative 1 is positive 3. I'm going to subtract 5. Y equals negative 3x minus 2. And there's the B part. Okay. Are the graphs of the lines parallel or perpendicular? Explain. So to determine parallel or perpendicular, I need to know the slope of both lines. Okay. So the slope of the first one is 5. And know that for the second one, I need to put something in standard form into slope-intercept form, so I got to solve it for y. So if you remember, the shortcut for slope was negative a over b. Or I'm just going to solve this for y. I'll do the shortcut one in a second. So if I add 21x to both sides, I'm going to get 3y equals 21x minus 63. I'm going to divide by 3. And remember, the only number I really care about is this one. I care about the slope, and that's y equals 7. Okay. So to me, it's looking like no, they're not parallel. Oh, it doesn't say parallel perpendicular. So yeah, they're not parallel because they're not the same slope, and so that's why they're not parallel. If they were parallel, I would have had to get 5 here. Okay. Write the equation for the line that is parallel to the given line that passes through the given point. So here's the given line. It's negative 5. So anything that goes through this point that's parallel to that line is going to have the same slope. So I know then that I'm going to use point slope again. So I'm going to use this point, y minus 3 equals, my slope needs to be the same, so negative 5 x plus 6 is the answer. Perpendicular, I have to find the slope of this line. So same problem, but these are perpendicular. I have to find the slope of this line. So that is negative a over b, so negative 1 over negative 9, which is 1/9. Again, if I subtract x from both sides, I get negative 9y equals negative x minus 12. And then when I divide by negative 9, the only thing I really care about in this problem is the slope of this line, which is 1/9. So there's my slope. And then I'm going to use this point. So point slope form, y minus 9 equals 1/9 x minus 4. And we are done. It doesn't tell us to put it in slope-intercept form, so we can leave it just like that. Okay. So I did show you the shortcut, negative a over b for slope, and I also showed you how to solve it for y to get the same 1/9. All right. Tell whether the lines for each pair of equations are parallel, perpendicular, or neither. So the rest for the next couple of problems that we're going to do looks like just one problem. Okay. And let's see here. So parallel, perpendicular, or neither for this problem. So I know the slope of the first line. That's nice of them. They gave that to us. It's negative 1/3. So two numbers I'm looking for. I'm either looking for negative 1/3 for the slope of this line, or I'm looking for positive 3. That would be perpendicular. Okay. If I get a slope of negative 1/3, that means they're parallel. If I get a slope of 3, that means they're perpendicular. If I don't get either of these numbers, that means it's neither. So solve this for y. I'm going to subtract 6x from both sides. Negative 2y equals negative 6x plus 16. I'm going to divide both sides by negative 2. Y equals negative 6 divided by negative 2 is positive 3. These lines are perpendicular. So the slope of this line is 3x minus 8. The slope is 3. It is the negative reciprocal of negative 1/3, so the lines are perpendicular. All right, describe how the graph is like the graph of y equals the absolute value of x and how it's different. They're both have a shape of a V. Okay, they all have a slope of looks like negative 1, positive 1. So this side's positive 1 up 2 over 2. So yep, it's the slope of 1 and the slope of negative 1. So the only thing we're doing here is moving this down 8. So this would be y equals the absolute value of x minus 8, with the minus 8 being outside the absolute value symbol. So all we did was translate this down 8. So this would have been my original parent function. Okay, see if we can get that to good. All right, write an equation for each. So the translation of this, so up 11 units. Remember, up is outside the absolute value. So, and what you see is what you get. So y equals the absolute value of x plus 11 is the answer to that. If it had been, let's say it was, let's do like 11 units right. All right, right is forward. So we're looking to draw that line at 11. Okay, and that just means it's the opposite. It's inside the absolute value equation, and we're going to do the opposite sign. This would be y equals the absolute value of x minus 11. That would be a right move there. Okay, which you can't see, so there we go. All right, let's take a look at, we're going to graph this by translating it. Let me get my graph paper out again. So it's the absolute value of x plus 6. That was the problem on our paper. Remember, this is a horizontal translation, so I'm moving it left or right, and I'm going to move it opposite the sign. So it's plus 6, so I'm actually going to move backwards 6. 1, 2, 3, 4, 5, 6, which puts me way over here. And it's still the V with a slope of 1 on the right side and negative 1 on the left. And there's my graph. All right, and that was number, looks like 31. So now we're on 32. What is the solution to the systems of equations? Well, in this problem, 32 here, they both are set equal to y, so I can set them equal to each other to solve for x. 3x plus 4 equals x minus 2. Solve for x, I'm going to subtract x from both sides. 3x minus x is 2x. I'm going to subtract 4 over here, and that's negative 2 minus 4 is negative 6. Divide by 2, and x equals negative 3. Now I'm going to plug that into one of the original equations. The easiest one in this is the second one. I just have to plug in negative 3 minus 2. So y equals negative 3 minus 2. Y equals negative 5. So my solution, negative 3 comma negative 5. All right, and that is the answer to that one. All right, tell whether the system has no solution, one solution, or infinitely many solutions. So if we look here, you can graph both of these to do this. All right, or we can just do some thinking. So let's do some thinking. First off, they have the same slope. Okay, and they have a different y-intercept. So these are parallel lines. They never intersect. Therefore, there is no solution. Okay, a slope of 4 at negative 2 might look like this, and a slope of 4 at negative 3 might look like this. They are parallel. They do not intersect. There is no solution. Solve each equation or systems of equations by using substitution. They're all solved for y, so this is just like the problem in 32. Nothing different. 2x plus 6 equals 3x plus 7. I'm going to subtract 2x to get x on the right. I'm going to subtract 7 to get negative 1 on the left. And then I got to plug it back into one of these. I'll do the top one. So y equals 2 times negative 1